2.2.7 and 2.2.8 properties of metal alloys and conductivity. So you know, metals have giant structures with strong metallic bonding between the delocalized electrons and the atoms. And it's the outer shell electrons that can move from atom to atom, which are delocalized. This means that most metals have high melting and boiling points. Now you might remember us saying group 1 metals, they can be cut easily, and often they have lower melting points, but generally the general rule is metals, pure metals, have high melting and boiling points because they have strong metallic bonds. So pure atoms have atoms that are arranged in layers. Now these layers can slide over each other easily, and that gives us some properties of pure metals. Pure metals can be bent and shaped easily, so they are malleable. They can be drawn out into wires, which means they are ductile. So those are the properties of metals that you need to know about, and the reason is that the atoms are arranged in layers which can slide over each other. But we use metals all the time, so how can these metals be soft and malleable and bend easily and be pulled into wires when we use them all the time? If that happened to your door key wouldn't work in the lock. Well, metals are made stronger and harder by mixing them with other metals. What this does is it distorts the layers, so the layers can't slide over each other easily now, which makes them harder. We call these alloys. A mixture of metal atoms or a mixture of metal atoms and carbon is called an alloy. Metals are good conductors of electricity because the delocalized electrons can carry charge through the structure. Make sure you get the idea of it doesn't just carry charge, it carries charge through the structure. Metals are also good conductors of thermal energy. That's because when you heat them up, the delocalized electrons can move faster through the structure, and it's the movement of delocalized electrons that carries the thermal energy.